Let me give you an example of completing the square when this is an odd number. So first let's sketch the graph. So sketching the graph, the intercept is at -10 and it's going downhill because it's a -5, so it's going downhill. And then it wants to do a positive quadratic. So put your pen nib here, take it down and then turn it around here, straight up. So that's what your graph looks like. Our job is to find the two roots and the vertex. So to do this, we would complete the square. So your eyes should zoom into these two terms, and it's always half of this this coefficient of x. It's always half of that 5. So that would be, half of it would be 5/2 squared. And then you take away the rubbish. What's the rubbish? Remember, if you were to use this, x minus 5/2 and then x minus 5/2, because that's what squared means, times by its exact same self. Take away the rubbish. The rubbish is this thing here. 5 would be this times this. So that will be 5 times 5 will be 25. And then 2 times 2 would be 4. And then you drag down this 10. Drag down the 10. So now it's single number, merge them together. In order to merge them, you've got to turn this into a fraction. So imagine this as a 10/1. To add or take away fractions, the two denominators have to be the same. So times top and bottom here by 4. So that would be 40/4. So that would be 40/4. Same denominator, so we can merge them. So you've got to imagine the number line. If you stand at negative, remember this negative belongs to that 25. If you stand at -25 and then you take away 40, you will end up at somewhere over here, which will be -65. So merging these two together would be negative. Merging these two together would be negative 65/4. Okay, so. Now when you get to this stage here, we can work out the vertex. And remember, it's always the opposite. So here, negative means you actually move it to the right. So this will be 5/2. Straight above the vertex would be 5/2. So the coordinates here would be something, comma something. Well, that something is actually 5/2 across. 5/2 across, and then you drag it down by this amount. So that would be -65/4. So the coordinates for the vertex would be this. To find the two roots, put 0 into the y. Put 0 into the y, and then rearrange it to make x a subject. Because if you want to find the two roots, what's so special about the two roots? The y value of the two roots will be 0. So you put 0 into the y. And then it's just a matter of solving x. So rearrange it to make x a subject. So rearranging it to make x a subject. Add this block to both sides. So that will be 65/4 equals that thing there. And then square root both sides. So square rooting both sides will then give you this. And then you get two versions, the positive version and the negative version. And then add this 5/2. So you add that 5/2. So 5/2 and then plus minus root 65/4 equals x. So what that means is, imagine you're standing at 5/2. So imagine you are standing here. This is you standing here. That's you standing there. And then if you add this weird number, it will take you to here. And then if you take away this weird number, it will take you to here. So the coordinates here would be something, comma something. Well, the x coordinate here would be you standing at 5/2, and then you add that weird number there. You can jump to a calculator and work it out. That would be this much across. And then how high up is it? Well, it's at a height of 0 because it's on the it's on the x-axis. So y will be 0. And the coordinates here, hang on, let me think. Let me erase this. So the coordinates here will be something, comma something. Well, it has a height of 0, so let's put 0 in there. And the x-coordinate would be, imagine you're standing at 5/2, so imagine you're standing here, or here, and then you take away this amount. You take away this amount, so it will take you to here. So let's start again here. Imagine you're standing at 5/2, and then if you minus this amount, 65/4, then you would go back to here. And don't forget it has a height of 0. So from this, we can always find the vertex, and we can always find the two roots by completing the square. Okay?